Okay, hello everyone. My name is Dominik Zülke, technical consultant from Microsens. Today we want to give you they're coming. Good morning. So I want to introduce a little bit about Microsens and our IP light technology. So Microsens, the company, I will introduce what is PoE according to the IEEE. What is DALI? Because this is mostly the standard we are compared by. So what is the difference here? And also standard switch luminaires. So in the end, we have different types of devices for PoE, building and room automation, and at the end, functionalities we can create out of those devices we have. And also, or maybe we just wait a minute. So now more and more coming in. Hi. So let's begin.
I just start over. It was just 1 minute, so it's okay.
Yeah.
Just stop the recording and start again.
So what is Microsens? We started 1993 in Hamm, and from the beginning we built network automation mostly in the industrial and the fiber optic transport part. And 5 years ago we also started with the idea of bringing, instead of just fiber to the office, also automation from the network to the office. So in the total, we are now more than 25 years expertise in network and also now in network automation. So, but why? And we always also do this. So in the beginning for network and IoT, we just have the room automation and the building automation. Most of those are independent technologies or even solutions, so they don't be combined together. They just be there in the room and automate the light, maybe the temperature and the blinds. And we have the main air handling and most other units, which are also working independent in this area. But now we need more and more that those functionalities being extended by the need for the facility management, which wants to know both what is the actual status in the rooms and the main facilities. The user also has to be integrated, so he wants to control, instead of just the light in the room, he wants to also control or get control over his desks and typical big area working rooms, and additional the revenue or the facility management, the owner of the building wants to get a feedback of all his users inside and also the technique inside of his buildings, which he can use to give new opportunities to the customers or the lessees as a dedicated solution and an improvement against competitors to say, okay, you have more access, get more information instead of just getting a working place there. So to get all of them together, we bring those in an IP network. But still, even if we say they are all on IP, it stays like that the room automation and all the other topics are working independent from each other. So we have not a direct connection that the air handling unit can communicate with the room. He cannot communicate directly with the facility management. There's always a gateway needed. So to bring those together, we now have the IP network. We also have to bring the technique inside of the rooms, and the other aspects together, and let them speak over the network with each other so that they really grow together. And information can be exchanged between all of these players in the building. So by this, we can create a solution which shows all of this necessary information to everyone in a single on a single site. So this is the view maybe for the facility management. Just the plain room with an interface can be shown to the user. And for the owner of the building, he wants to see maybe just the key values of how much room is at the moment occupied, maybe how much he can double rent those. And to do so, we need all of this information combined into one single solution. So that in the end, it's unnecessary what is in the building, because what now is just the visualization of the building, and this is by bringing all of this to an IP network. So we started, what I said earlier, we had network components for nearly 25 years, and now also with the smart building solutions, we bring also on top of our network hardware an automation layer to automate all of the needs in a building. So we began with the enterprise, industrial, and optical transport, the profile line, like in industrial grade networking, and all of those which we show here, it's one common is that they all have the same or share the same firmware. So if we found a solution in a problem inside of optical transport, which has to be fixed, all of those go to the same core architecture, and the firmware is being given to all of these devices at the same time. So a fix always is applicable to all of the devices. Instead of that, we have to develop a solution for each individually. So the common is all of them share the same firmware, the firmware generation 6, and also the devices from the smart office part. So, but just with this software, we don't get the full combination. The next is we also have now the firmware, which is the same. We have our Smart Director app, which helps to automate the light and room automation in a very fancy and easy way, just by enabling the functionalities in the room in a web interface, also on the switch. So there's no additional software tool needed. We have a micro RTS. This is a soft PLC which can be installed on this switch. So we have the a more function like a loop automation, where we can write our own code in an official, in standard way, like we had a PLC, but not in a dedicated hardware environment. It's on the same network devices which are already in the present. We now also have a PLC on top. And in the end, the Smart I/O controller or our controllers are working also independently. Like we can get the information from those devices by MQTT to get just a field layer, and the automation doesn't has to be all on Microsens. It can also be on third-party devices which support the open standard MQTT. So for short, what is PoE or IEE 802.3 BT? This is the new standard with PoE Plus, PoE Plus Plus or Ultra PoE. It's a standard, so all of the devices are interoperability between different vendors of switches. So our devices can also be connected to an HP or Cisco switch and is powered and gets the network, the connection to the network. Those devices can have a dedicated power class from 1 to 8, which ranges from 3 watt to up to 90 watt. which can be delivered to the device. Our devices, specific ones, can be powered up to 71 watt and distribute then 50 watt of total power to LEDs. So we have different devices I'll show you later. And also we have here 1 gigabit Ethernet and just use standard Cat5 wires for the installation. So like this, we just have a plug and play solution for devices. The power comes from the same cable, which is also there for the network, which means we just have there's no wrong connection. We have an technical we have a technical solution to show if the connection is there. We don't have to look into the information, because the information is being secured by the TCP stack. So when there's a link and the TCP stack is working, all of the information is going from the device to the automation layer. So this is a very easy way to set up a new connection to transport the information from here to another part. There's also no electrician needed, because we are here working with self, so below 60 volt, and we can we just have a simple plug and play solution. And why I say this is because we are mostly compared to DALI, because we are talking here about a light solution from the network. And often in the project we are asked, so what is the benefit across DALI? Because what is DALI? DALI is a 2-wire bus system, which is installed across the normal 230 volt power supply to each luminaire, to also create the interoperability between different vendors of lights. But there is a difference. So in a normal installation, we can just go up to 64 luminaires and also 64 sensors. So then a new loop or DALI loop has to be created. We need a new DALI interface or DALI power supply. And those devices, some can be powered, but most of them are just relying on a different power input. So we have along to the DALI network, what is called just a 2-wire connection between all of those in a daisy chain. We also need a power supply, which also be put along from one device to another in daisy chain. And when we say we can do this maybe by a 7-wire normal installation cable, the problem is always we have we combine here 230 volt with 16 volt, which is used by DALI. So we always need an electrician here. So the installation, an exchange of a light, has always been done by a certified electrician. And we have the problem that all of these connections here are just 7 wires in a daisy chain. So if there's a mismatch or a change and there's a wrong connection, we have to look where is the wrong connection, and we cannot just say, okay, when the connection goes in and goes out, there is no failure proof like an RG45 connection, because you cannot put in the plug in a wrong way. So most of those, so this is why we mostly be compared by DALI, and what is the difference is we can say the failure proof and the lack of needing an electrician against DALI. But still, so both of those we can say this is controlled and dimmable. But what is with the additional lights? Because in a standard way we just have a way we want to switch lights on and off, maybe with old chandeliers or some very decorative lights, desk lights, which are not DALI or PoE feeded. We also need a way to operate those. So the idea is we're facing all of them by a smart I/O controller, which is just a plain I/O board, but with the possibility to power devices over PoE, because this device is also powered by PoE. You can power devices with up to 20 watt out of those. We can mount them on a rail, and we have 24 volt DC. So like this, we just put a relay to switch standard circuits and operate those in the same way along with our PoE lights. So our devices, just in short, because this is the first thing, is the smart light controller. This is a PoE device capable of directly driving LEDs, because this is a constant current LED driver with a PoE and a sensor interface. He's capable of powering up to 20 watt LED power with 20 to 50 volt DC and at maximum 1 ampere. The device automatically calibrates himself to the connected LED, and it's then dimmable from 0 to 100%. With a connected sensor, we also get the motion, humidity, temperature, and brightness. And because this is a full IP device, it doesn't have to be connected to the same switch where the automation is going. He's just have to be on the network. So wherever we put those devices, we can operate them, because though all of them have an individual IP version 6 network link local address to be controlled without need of an DHCP or an IP version 4 layer, which has to be addressable from all of the from the network, because we rely on IP version 6. So from the send out, at the installation, this is a worldwide unique IP address. So without need of giving him an IP version like his own IP address. A new version of those is the smart light controller, with 2 channels, because what we faced often in project was that the need for dual tone lights, which are capable to change the color according to need, or in an automated according over the day. From the beginning, like this HumanCentric Lighting or circadian lighting, it's named. We start in the morning with a little dimmed warm light. Over the course of the day, we increase the intensity and also increase the color temperature to a cold light on midday, and to the evening we go we decrease the intensity of the light and also the color temperature back to a warm light. So when people leave the office by the end of the day, it's not a hard change to the outside light. So we follow the more human way of the outside light. So also with the new smart light controller, we increased the capability of the output, because we're relying here on now ultra PoE or PoE++ with up to 50 watts. But this it stays the same. It's an IP device. So each luminaire, this device can be put directly inside of the luminaire, is now an IP device with a unique IP address to operate. What I said earlier was we also have those sensors. This is the motion sensor, which can be connected to the SLC. So it's also have the RJ45 port. So there's no wrong connection. It's just plug and play. And what I said earlier was when we connected those to the SLC. It's just an increase of functionality to the SLC. So the device stays the same. So this is not now getting an additional IP device, which I have to address. It's just increasing the functionality of the SLC. So when I connect it, the SLC automatically now publish his measured values. And we have here also feedback input, because we can change with an RGB LED the head of the motion of the sensor to give a visual feedback to the customers. What we did was, when we have just a light installation just with sensors, so like a motion detecting the motion detection, the light goes off when people leaving the room, and we had a problem that people started to search for the light switch when they enter the room, because they didn't see that the room is automatically switching the light on and off. So we changed the color to blue in the ceiling, and after, from some people it was just 1 day, for others it was up to 2 weeks, but in the end it was in the least 2 weeks. The people know that when the sensor is blue, they just have to enter the room and know that the room is just waiting for them. So the light is not switched hard off, it's just waiting and automatically switches his light when someone enters. And after 2 weeks, the people just goes in and outside of rooms without noticing that or searching for a light switch anymore. So what I said earlier and introduced was a PoE solution. So all of those devices are individually connected to a PoE switch, and on our switches, the automation layer is connected, so we can create very granulated solutions. Like we just count the LEDs inside of inside the project, the needed sensors, and then calculate how much PoE ports we need to put those in a more cost-efficient way. We, in the end, put the CSLC. So in the end, it's the same devices like we seen earlier, our network switch. This is the right part with the 3 network ports, and the SLC. This is the 24 ports here inside of a housing. So this is not just put all of these devices together. This is a special designed PCB, and we eliminated the PoE part in between. So we just go by a rack mount device, which has the automation layer, the network layer, and the feed layer in one housing. We still rely on structured cabling by using RG45. So the same wire done for network, we can now also use for powering the LED. But this is not a real network port anymore. This is just the output with the 2 wires separated on the 8 wires from a CAT cable. So by doing so, we have 24 luminaires. We just need a plain power supply and have just a standalone. So this can also operate standalone, but with the benefits of having our automation layer with an user interface, controlling of light, and many more features like the PLC can also install here. So, but it works standalone, or can be stacked with more than a multiple of those, without depending on PoE. So what we proposed is we have a light provided by the network. So the light is an integral part of the existing IT network and not connected by a gateway through or to it. We have intelligent control and monitoring by the field devices itself and on the automation layer. We have a simple integration of sensors. This means just plug and play There's no addressing of the sensors. It's automatically just increasing the function set of the field device or the light controller. And we can create out of those an additional services, like what I said. We have the human-centric lighting, the automatic light adjustment, like we call it auto dim. So we get the brightness inside of a room and compare it to the set point to reduce the lighting. So when there's enough outside light coming into the room, we reduce the electrical light or the artificial lighting to save energy. We can create also a function for, or we have created a function for an follow me light, which means for runways or hallways, the light doesn't have to be on the full course on and off. The light follows you along the floor, the corridor. So when you enter the corridor and maybe stop on the half, only the half of the light has to be on, instead of that the full corridor goes on. And we are not, and when we see all of this power consumption on a daily base over the course of a year, we can save up to 50% of energy according or compared by a standard installation with motion sensors, because all of this all of the luminaires are individually and independently controllable. So what means this for an installation? So as said, we have in a project step. So we have at first the cable installation. There's just the site. Everyone is working here. So at the first step, we just plan a network installation. Each luminaire has now a network port. This is very easy, just RG45. From a central installation point, it can be in a room, in the ceiling, because the devices are all with extended temperature range. We plan the cabling. The next step, when the rest of the installation from the other vendors is done, we come with our luminaire. We plug it inside, just plug and play it with a click to the existing connection, and the light immediately goes on. So while we install, the light is working. So we go from one light to another and install it. On the next step, we are finished, because here it's all done. And what we bring also with just an PoE light is we have scenes, in total 32 scenes. We can control the temperature, the light intensity, automation, like human-centric lighting, auto dimming, or just plain on-off, switching of standard main devices. We have human-centric light, follow me. We can control blinds. We have the temperature control. We have also temperature monitoring, a user interface coming from the same device without need of a cloud or an internet connection. All of this hosted on the same hardware, and additional, we have a logging inside. So we also log all of this sensor and actor data to give it a further use in a more for maybe upcoming solutions people can create on their own.
Excuse me, can I ask a question?
Every time, please.
About these sensors now, I understand they are the first and foremost feature is to provide the perfect lighting conditions and management of the light, but can they also be used as like a presence detector for the administrator of the building to make sure there is no people in areas where there should be no people during certain hours?
Yes. So this is what I said by creating more features out of the existing data. So in total, it's always going to, you need the data from your building. What in the end you create out of this is on yours. It's only also on your part, or on the part of the So we have an.
But is this part of the management interface already, that you can set up a schedule? I mean, after 8 o'clock in the evening, we should have no presence in these areas, and
Yes.
if I have, then somebody will be notified.
Yeah. So this is so when you say somebody notified, at first I think in the network and say, okay, I create because the on the switch itself. This is a full manageable layer 2 switch. We have scripting. We have an what is it called? We have scripting. We have a scheduler, and by do so, I would now just write a small script and create an SNMP trap that in the time from whatever we define, motion is detected. I create a message to the central management. Later, I will show you the central management, and we are at the moment. So the in 4 weeks we will have the what we call the motion heat map. This is like an time-based visualization of motion inside of the building. And along with those, we have an automated way to show that there's some motion in areas which are not accepted at the moment. So like you said, we have all of the building is been should be empty, is locked, and someone enters it and there's motion somewhere. We can create an alarm very easily to show to the administrator that there is something is happening there.
But also, I'm just fantasizing now, but also the other way around, could you also know if there is no people where there actually should be people? I'm
Yes.
thinking of elderly care. If you know, if you would like to know if somebody has been moving, you know, did they get out of bed today or not?
Yes.
Or any other indication of people, too little staff where there should be more staff, so forth.
Yeah,
that is also part of this feature set.
Yeah, this is so it's not an built-in feature because we didn't thought about those, but we what we said. I hope that it was said by me earlier. We are just so we are a company very focused on doing the on the project-based not invention, but on a project-based development of our solutions. So when you have a project, so I have no problems in seeing here a solution because we have the motion. We have as a dedicated data point. We have the possibility to create rules, and if not by scripting, we can do it by a full-fledged PLC. And we have a logging, and we also have an overall visualization of those data, of this data. So creating a solution, if it depends on showing if someone is moving or is not moving, this is totally open, and I don't see a problem here. It's just giving them him a name and create this solution according to a project. So I'm not seeing that. Not even so. Even you can do it on your own in your project because we are so open to customizing that you can create those solutions on your desk without that we have to create those solutions before. Because when I show you later more deep insight in our we don't have this much time, I suppose, to how to operate this. You can see that all of even if I said earlier this micro app, it's just creating the configuration for you. It's not that we have a black box which is just doing what we printed on the black box. You can create all of those also by yourself.
Okay.
So
thank you. Please continue.
Yeah. So what I've in total, I did 13 years of building automation before I come to Microsens, and I always try the most possible to give automators like me an working tool set, an open and working tool set to create the solutions the customer demands. Because even if I create according to the demands of my last customers a solution, I know for sure that the solutions for different customers will be different, and be as open as possible and to have a very good and flexible tool set instead of just a fixed solution is the best way to approach the market from my perspective. So what we said earlier is all just focused on light or building out room automation and light automation. I just give a few glimpses to going more than light. This means network embedded automation. So I said earlier, for software, we have this soft PLC. So why not go a step further? Instead of having just room automation, we also go by the next big player, the maybe air handling or the central air handling units, sanitary plumbing. All of those can also be controlled by the same network hardware already present, because even if we have a PLC somewhere, it's a standalone PLC, it has to be integrated to the network. So why put the same maybe CPU, it's an ARM, next to another CPU which does different tasks, put all of them to a single CPU, because the network is already there, and there we need the CPU for the management. But when the management is done, the rest of the time, this CPU inside of our switches does nearly nothing. So the idea is to put this scripting, or what's the next part, the RTS, the soft PLC, on this existing hardware, which executes the standard code written in like an Vago or an Mitsubishi ABB PLC code inside of the switch, and do this automation work. The next part is only to have the IOs, which is benefit of the PLC, that most of them bring the IOs directly connected next to them. So the problem is then we have to create a special designed cabinet, which is just configured to the specific demand of the project. So why not replace a fixed cabinet and bringing all of the wires from the floor to one centralized point? Also go the network way, because everywhere we have a network, so we can have a managed network, and we can create a network also for the IOs, so that my IO ports are not located inside of a cabinet in a central way. It's located everywhere where the field devices are located, like in the ceiling inside of a room, like in the technical room for the air handling unit. And we don't need this special designed cabinets. We can have a standard cabinet which with field cable push inputs, and connect all of my field devices to a standard smart I/O controller. Like we said, we have the possibility to power those devices, because this device is powered by PoE. And also we can power 25-volt DC devices in total per device up to 20 watt. And this means two valves in the ceiling valves for heating or cooling can be powered and controlled by one device with maybe an additional fire protection flap to get the feedback that the flap is open or closed, or whatever hardware we have in the room, or like a plain light switch, we can connect to those. But all of this located inside of the room. So when there's a connection from the field device to the cabinet, we talk about 30 meters. When someone has to do the service later and there's a problem, someone is sitting in the room, someone is sitting at the cabinet, and now they have to talk with each other. Why is the connection or the signal is not coming from the sensor in the room to the cabinet? When we go with the Smart I/O controller, we can see the start and the end point, and the rest of the information is just going by the Ethernet cable. So, and when we can say here, when there's a link, or when there's a link on the wire, everything is we don't have to look into it. How is the rest of the cabling done? Where is the information going? This is just, so when link is there, the network is there. This is failure proof, because when the link is broken, we can be informed by the switch itself that the connection is down. And for the rest, for the standard like an analog value, we can measure it from the input point here located on the device to the field device, because the idea is to put it as close as possible to the field devices. So also for service, I don't need 2 people, I just need 1 people who is looking directly from the connection from the Smart I/O controller to the field device. So that we in total have most of this architecture. We have the switch, which represent the whole network. It doesn't have to be just a single switch and the same switch. It can be whatever network port is available. We have our smart light controller. We have the Smart I/O controller. We have also the possibility to go by an Ocean with an just an USB dongle, because our switches has also USB interface, or we can go by whatever gateway available, as long as it speaks or it's available. It's possible to address it via IP. And then we have 2 solutions. The one is the micro RTS. This is soft PLC, which can be written, the program code can be written in an editor, loaded to the RTS, and then it's executed like a standard PLC. Or we can, for small applications, do scripting inside this. But for really building automation, I suggest we go by PLC. So, and what I said earlier was we have this motion heat map. This is the latest development we are working on to have we have the data, we store the data, and now we can create more more information out of it, which means we can visualize in a room layout how much movement is happening over time. This also means we can say for if there's which areas are mostly used, like when we have like a co-working space, we can say most of the time, the least of the time, the most of the time of a year, I have not more than 80% of use of my co-working space. So for the customer, in the end, it is can be an idea. So why not go 20% above 100%? So he can sell 120% of his rooms, because he knows never in the past he exceed those values. It's the same gamble like aviation companies do. So they overbook their planes just to have them at 100% use. This is something also to reduce the space needed for companies, and to give for the owner of a building a benefit. Why do automation? So our markets are nearly all over the world. FICO is here very convinced to also give them more information if needed. Most of those are our main competitors. So I said we did the last 25 years a very good job. So to do so, we have many big customers at the moment which are working with our technique, even if you don't see it on the first look where we are. And so I would like to thank you, and I wanted to share a little bit about what I talked about when I said we have the microscript and the smart office application inside of our switches. Any questions?
Yes, one more question, please. Are you considering, or have you maybe been involved already in projects where you are integrating your wired smart sensors and wireless sensors like LoRaWAN? We see many new applications for sensing, especially around lighting conditions, and they are battery powered and low powered devices like LoRa. Have you made any integrations with such sensors already?
Yes.
Or are you sort of planning to release your own set of wireless versions?
So we have already built-in. What we have already built in is the use case for. We have an ocean, which is our main goal because they are not needing batteries. Because we're talking here mostly, so we begin with battery-feeded, like HumanCentric, it's called in Germany, and mostly smart home supplier for sensors and actors. But the problem is when we go in a bigger scale for large buildings or large projects, you finish the change of batteries in the first device, in the last device, and you start at the first again. And it's to do so with so we had in the biggest installation yet is an hotel in Poland in Puro. It's Puro, Warsaw, where we did the automation. This is the biggest running project with the full integration. So we also we integrated the full room with PLC. There we have per room 10 light switch or switches, and one actor for the floor heater in the bathroom, and we have the room display, which is also connected via an ocean, but also batteryless. So and in 155 rooms. So in total, we have 1,500 devices connected in one project.
Okay.
And
interesting.
Yeah, this so the benefit is mostly you don't need batteries. The energy for the telegram is created when you press the button. It's just a little bit louder, the click, but this is enough energy to create the information and send out this information in an in an area of a room. Like we have in total 30 meters, but let's be clear, when engineers say 30 meters, in the real it means 10. But this is sufficient for room automation to do so, and we did a whole building with it.
Okay, thank you.
So this is now a look into our managed switch, and we have here the full smart office integration. So we see all the data points, and to go here very deep, I would stop here. But what I wanted to show is that at the same time, this user interface is also on the same switch. So this is a dedicated user interface. You see, this is resizable. So even if we maybe go by a phone, it's always the same. And we are relying here not on an app. So this is just a plain HTML. So you see, this is the same. It's just an HTML displayed here and rendered. So what we can do is it's all of this are configured also inside of the switch. We don't need additional HTML or something written code. it's just all of this parts here is configured. This is automated done if you configure the room, and you can use it just with whatever device is has the capability to display an HTML. You give the customer a user interface without additional connecting to a server or something, because all of this is built in. And when we talk about server, we can also go the next step. So this is all in a local area like a DDC. We can also go in a bigger scale to compare and combine information over more than one installation. So this is now a live view from the Smart Building Manager inside our office in Hamm, which shows the information in a combined way. So this is a single room, but we can also go by an overview. We have all of the installations here, like the corridors. We have the office I've shown you, the production office, which shows the layout. We have on the first input this to see this, and mostly like this, I would create the idea from if someone is entering the building, we have like an event system to just show you. But in the end, this is just plain. This is just a plain view of every BMS system on the market. But now we are starting to invent more and more solutions here. Like I said, this motion heat map. And no, it's not yet online, but in the next weeks we will have it. And maybe we can start again and go further to show you what we are then capable of. So, and now we are nearly in the end for today's meeting. I would like to ask, is there any more questions we want to address now? Because if not, I would like to say thank you. Thank you for your time. I hope it was interesting also for you. Feiko, do you want also to?
I just want to thank everyone for joining, and if there's any questions or if you have some specific projects you're working on, just or might be working on, or if you have some ideas, just contact Roger, and he will contact us, and we can set up a separate meeting with you individually, just to discuss some solutions for your companies individually. So, well, thank you again for listening, and yeah, hope to speak to you soon.
Thank you very much, guys. Talk to you soon.
Thank you. Bye-bye.
Bye.
Bye.